eLTER, Integrated European Long-Term Ecosystem, Critical Zone, and Socio-Ecological Research.
So, welcome once more. Today we will discuss about the eLTER platforms. So eLTER has two types of sites, so platforms, the sites and the platforms. And to clarify the concept of platforms, we have today Veronika Gaube from Boku and Daniel Orenstein from Technion University, and then Stefan Zacharias will talk about the sites approach a little bit, right? So welcome, and Veronika, you will start, right?
Not with the presentation, Stefan will start.
Okay.
We can directly hand over to Stefan.
Okay, yeah, thank you. Then I will start the presentation. Let's see. Okay, you should see the presentation mode now.
Yes.
So yeah, hello to everybody. So I was invited, or Thomas asked me to replace his position here in that meeting. And I'm happy to do that. So many of you may have already seen some of the following slides. At least, so I just checked the name of the participants here, and many of them I have seen virtually, at least in some of the other meetings where I have presented the concept of the standard observation and the site categories. So please excuse me if this might be a bit repetitive for the one or the other. So, but I think, however, as today's focus is on platforms, so I think it's a good chance, good option to refresh, briefly reintroduce the concept of the site hierarchies here as a kind of refresher. So I will focus mainly on sites as a key element of the platforms. And I'd like to show once more how this concept of standard observation is of essential relevance for the definition of site categories. And since sites are an essential part or a key part of the platforms, I think it's good that all are on the same ground when you start to discuss about the platforms then. So I have to sort out here. I have a kind of problem with my screen here at the moment. It's changing. Okay. So to begin, I want to show this very general illustration here. The infrastructure concept is based on these four main pillars. eLTER site or eLTER is aiming to gather information in the long term, documenting the long-term development of the ecosystems. So we are talking about eLTER as an in situ place-based research infrastructure. We aim to generate data at different spatial scales of in Natura sites. eLTER has a process orientation. That means we aim to identify, to quantify interactions of ecosystem processes. And last but not least, and this is the unique feature of eLTER, is the whole system approach. That is, so we aim to describe the whole system, including the human interactions. But then you see also the conceptual roof of eLTER. Everything we are talking about here is aimed to be fulfilled with a representative coverage of the major, as written here, terrestrial and aquatic ecosystems in Europe. And it's clear to achieve that goal, it requires an adequate number of on-site locations. So, and in order to exchange data and or knowledge effectively between the sites, standardization and harmonization is key. And so that means we need to define what we want to measure and how. And so that means to begin, we had to define the variables we want to record. So we set up a process. So after it was a lengthy process spanning several years, but we have now identified the variables that we think that and agreed that those variables are relevant from both a disciplinary perspective and most importantly also in relation of whales. Again, a brief reminder, you see the essential elements of the concept here. A site we want to label as eLTER has to cover the ecosystem structures with respect both the abiotic characteristics but also the biotic diversity. We aim to cover the ecosystem at the process level. We want to describe the energy, water, and matter budgets. And following eLTER's whole system approach, also the critical socio-ecological drivers should be described or be part at least of the concept. So, and the variables to observe should be highly sensitive to environmental change, but also of relevance for environmental monitoring. And last but not least, we tried to keep it, to optimize it in a way that we can aim for parsimony here. That means we want to keep it simple in order to secure the long-term maintenance of our infrastructure. The slides are not changing. I have problems here with my now. So in eLTER, when we talk about standard observations, so this is a concept we have developed which represents a kind of trinity of the type and the scope of the environmental variables we want to record. But an essential part of the standard observation is also the definition of the methods and the protocols we want to apply. And the most important criterion for the selection process is, of course, the scientific relevance. That means the importance, the scientific impact of the variable we want to measure. But then, of course, we need also to secure the scientific flexibility of our sites. So that means we have to keep the balance between the service component of eLTER and the scientific flexibility. That's why we had to take into account, when we made our selection of the variables, also the general feasibility. That means, for instance, what kind of expertise is needed to conduct a certain measurement, or how complex the required infrastructure in terms of sensors, for instance, and the costs in general for the required hardware is. What is about the staffing resources that are required for instance, laboratory measurements. And another criterion that must be taken into account, especially when we are talking about the definition of the methods and the protocols to measure the variables, is the coordination with other existing RIs and existing standards. And this trinity now of the criteria that has driven the decision on the variables, the methods, and the protocols. And we are at the very moment at the beginning of a process where we now have started to define the protocols for the variables that are seen as of priority in the sense of eLTER. Now we have selected our variables, and we need to translate them now into the specific site design concept. That means we have to consider the Wales concept on the one hand, which aims to integrate about or across the different spheres, from the atmosphere down to the geosphere. It also aims to describe the ecosystem characteristics, as said, including the abiotic properties, the biotic, and the budgets. And additionally, we have to define the socioeconomic boundary conditions. So that means we have to make a selection of variable, and that brought us to the next challenge. This composition of variables we are making is specific for the habitats. So that's why, in particular, when we are talking about the relevance of the standard observations, it's clear that the relevance of each of the standard observations is specific for each habitat. And the selection of the standard observation itself has to be habitat specific. So that's why we developed a set of standard observations specific for each habitat. Some of the standard observations, for instance, climate data, must be collected for all habitats. Others, for instance, when we think about aquatic measurements, they are not needed when I think about, for instance, about the forest ecosystem. So, and to come up and to develop these habitat-specific composition of the standard observations, We developed a generic habitat classification scheme. We adapted it from the unit habitat classification scheme and ended up with a group of 9 habitat groups, which are seen as of relevance to classify our ELTER sites in Europe. And you see the list of the 9 habitat groups here. So the scientific requirements of ELTER, as said before, need a number of sites. So we need highly instrumented sites on the one hand, but in order to achieve the goal of the geographical coverage of the European ecosystems, it's clear that we also need additional sites to fill the geographical gaps. And this is expressed in the concept of the site categories we have developed. There are 3 site categories that are relevant from a formal point of view with regard to the future RI. And these are the site categories 1 and 2. And then we have the concept of the platforms. For each of the 3 elements, the platforms and the 2 site categories, the whole system approach is one of the critical criteria. That means these 3 groups of the site hierarchy concept, the category 1, the 2, and the platforms, have to be compliant with the holistic approach of the environmental monitoring to be implemented in ELTER. And there is another category, the category 3. From our perspective, this can include all sites that feel they belong to the ELTER research and the initiative in terms of the content and structure, but do not meet the criteria for an ELTER site for the time being. So in a sense, these sites can be considered as associated sites or sites under development, but will, for the time being, they're not part of the formal ELTER RI. And the implementation of this concept into the ELTER network requires that the in situ facilities are labeled somehow. And so the ELTER labeling will be a process that will be applied to all ELTER in situ facilities, both the sites and the platforms. And in very simple words, it's just the assignment of an in situ facility or in situ structure to a specific category, either a site or a platform. So this affects, as said, both the site and the platform level. We have to define a set, also we have defined a set of mandatory criteria. And so it has to be checked whether these criteria are met by the site or the platform. But this also has levels with respect to the whole research infrastructure, because this labeling is also a procedure that allows us to secure, to guarantee that the quality and the availability of the data and the services is meeting the criteria we have here in terms of ELTER. So when we are thinking about the criteria that are relevant for the site categories, we have this, I can show you this simplified table here. It lists the main criteria that have to be applied either for category 1 or category 2 site. And you can see here that for both, for the category 1 and the category 2, the holistic approach has to be followed, and that means all spheres have to be covered, at least with the basic observations and methods. I will give you a brief intro in that concept in the next slide. And then you see there are some criteria which are only relevant for the category 1 sites. And one of the most important one is that for the category 1 site, the so-called prime standard observation method has to be applied. And what it is, you will see on my next slide. And then you see some other criteria, the all-year guaranteed access. So you have to define some roles for people who are responsible for the site coordination or the data management. We need the documentation. And of course, the long-term operation has to be secured at an institutional level. So how is this now reflected in the concept of the site categories? As said, the standard observation provides a list of variables that have been selected based on our disciplinary expert perspective, let's say. And in the vast majority of cases, I would say these are variables describing state and fluxes in the different ecosystem compartments. However, in standard observation, as said before, not only consists of the definition of the variable, but also on the definition of the methods and protocols. Remember, we have also talked about the feasibility and the costs. So all three elements together are forming now the standard observation. At the very early stage of eLTER, we also planned that we provide some kind of flexibility in the choice of the methods to, let's say, accommodate the site hierarchy criteria. And so therefore, for the most of the standard observations, we have defined two methods, both a prime method and a basic method. Let's see whether I can switch on the laser pointer here. Yeah, the prime and the basic method. While the prime method can be seen as a kind of gold standard in eLTER, you can think about the basic method as something like a kind of minimal requirement in terms of eLTER. In order to fulfill, so when you think about concrete examples, it can be when we are thinking about the energy balancing. So for instance, you can set up an eddy flux covariance tower to measure the components of the energy fluxes in an ecosystem. This can be seen as a prime method. It's a very extensive infrastructure. You need a lot of expertise to operate the sensors. But you can also try, for instance, to estimate the net primary productivity based on a visual inspection scheme. So that can be seen as an example for a basic method, for instance, in terms of the energy budgeting or the carbon budgeting. What you see here is a scheme to illustrate how this is related now to the site category concept, and you see an example for a category 2 site here. In terms of the criteria which are relevant, a category 2 site has to fulfill the whole system approach. That means we have to provide, the category 2 site has to provide standard observation for each of the 5 spheres: geosphere, hydrosphere, biosphere, atmosphere, and sociosphere. But in terms of the methods, the category 2 sites have the flexibility and the option to apply the less extensive basic method all the time. And if you do that for the full set of the predefined standard observation which are relevant for your specific habitat, you fulfill the criteria in terms of the labeling. You can apply higher standards like they are defined in the prime methods, but it's not relevant for the labeling then in the end. If a site is to develop towards a category 1 category, then the scheme changes a bit, because it's necessary then to make a selection and to implement a specific research focus or observation focus on at least 2 of the 4 spheres here. You see here an example for a category 1 site, which has a specific focus on the geosphere and the hydrosphere. This is a decision taken by the operating institution or the PIs. And for those 2 spheres, which will be part of your category 1 label, then in the end, you have not the flexibility anymore to apply the basic method, but for those 2 spheres, it is required to apply the prime method then, which delivers a higher quality of data for these 2 spheres. This is the difference between the main difference in terms of the variables and standard observations when you think about the category 1 and the category 2. So, and these criteria I've just described formed also the basis for for a network-wide screening. We started in March last year and repeated once more end of the last year. And the purpose of this screening or survey was, on the one hand, to raise awareness for the upcoming process of the labeling, but also in terms from the perspective of the network design, to first to detect major objections maybe, but on the second to get an information about gaps that might exist and are critical in terms of the general objectives we have defined at the very beginning in terms of the future LRI. So we set up an online query and addressed in the first round each of the more than 400 sites in all European eLTER countries, asked them to indicate and forecast the potential, let's say, level of compliance with the labeling criteria. And so in the result, we got initial information about the situation in the countries, but also at the European scale. And this allowed us to analyze then the level of representativity we have already achieved or can achieve at the moment. So the results of this survey were then fed into a statistical model, which has been developed some years ago. And this allowed us to analyze the situation of the existing in situ network at the European scale. And as a result of this analysis, we were able to identify and prioritize existing gaps and to develop potential strategies to fill such gaps. And you can see the main results of this first analysis we did here on the left side. You see some regions are red. That means based on this approach, we have identified there more critical gaps, let's say, in terms of the geographical coverage we are aiming for. So, and at the moment, there's a process ongoing. So we have some discussion with the respective countries in order to identify options to fill this gap by bringing in new sites to, let's say, improve the distribution of sites in that specific regions. And so now, very close to the end of my brief presentation here, I want to give you a brief outlook about what is coming next or what we are developing in order to support, in particular, the site PIs and the national networks. So with in order to support the planning at the site level, we are currently preparing a tool that will allow us to analyze the current status of the infrastructure at the site level relatively quickly. And above all, and this is the most interesting feature of this tool, it will provide you with a cost estimation about potential upgrading costs. When you, for instance, have a category 2 site and want to upgrade it to a category 1 site, with that tool, it will be possible to do that very easily. Here you can see a first screenshot of the tool. This is currently in the beta test phase. So the idea is that you can make selections of the site categories and the habitats representing your site. And then you will receive an automated selection of the standard observations that are relevant for your site. And then you can simply click and select the standard observations which are already in place at your site or those which are still lacking. And then there's a result section then, and you get at one glimpse then an estimation about the current costs, both for the measurement equipment, but also about the resources that are estimated to be required for the operation. For instance, labor hours or laboratory costs and something like that. So that in the end, with that tool, it will be very easy to get a first rough cost and estimation for the upgrading costs at the site level. And this will also be then an important tool for the national coordinators to get an overview about the situation at the national networks and the costs they have to think about to set up the national network with all the criteria we have discussed before. And that's it, what I wanted to show you here. I'm happy to answer questions for the platform.
So this is a nice transition towards the going more into details with platforms. Please.
Okay. Yeah. Thanks, Stefan, for giving this overview for the sites. Before Daniel will start with the categories of platforms or the specifications of platforms, we thought it would be a good idea to also give a brief introduction to what social-ecological research as such is or should be in eLTR before we go ahead with again specifications of the platforms. So this is why I will now dig more into the contents. I will start with this very old but still valid figure, I would say, which shows the ambition of eLTSER. So the green part, the left part of this graphic, represents the classical ecological research with a focus on dynamics and patterns within ecosystems, different ecosystems, which is the classic LTR. And while the extended LTR, in contrast to the classical LTR, includes more or less human-modified natural systems, the eLTSER has to deal with social-ecological systems as a whole. So this results in an analysis of interactions between ecosystems and socio-economic systems. This is the idea of eLTSER also within eLTER. And in one of the first papers that deals with the question of what are the relevant themes and elements needed to be integrated in the design of eLTSER, the authors pointed out more or less 4 general themes. These are socio-ecological metabolism, which is what is meant by socio-ecological metabolism. It's the question of how much resources are used by human societies and consequently how much material is extracted from ecosystems for socio-economic activities. And this use and extraction of material leads to changes in land use, also in land use intensity and in landscapes, which is the second element mentioned in one of these first papers. And each type of natural resource use, so the way how resources are extracted, is embedded in a kind of a governance structure, which again has a clear impact on how resources are extracted and used. And finally, the fourth major theme in eLTSER is communication, knowledge exchange, and also transdisciplinarity at a regional scale, but also at the national and supranational level. And based on these prerequisites or 4 elements needed for eLTSER in eLTR, the differences between classical ecology and social ecology are also presented in this table, where you can see, of course, classic ecology has a focus on ecosystems, while the social ecology focuses on social ecological systems, which has an effect on how humans are treated in the analysis. So in the classic ecology, human populations are seen as populations that cause kinds of disturbances in ecosystems. In the social ecology part, humans and societies are engaged in an interactive process with the natural environment. Also, the methods and the approaches differ. So natural science approaches are based on observation, analysis, explanation, while in the social ecology, inter-transdisciplinary approaches get involved, and also social ecology is aware that the research may also change the system under investigation. So doing long-term socio-ecological research on a specific platform or region has an impact and effect on this region. The products are very similar. It's also data, models, understanding of the system, which is typical for classic ecology. The same is the case for social ecology, plus socio-economic data, also qualitative data that are important to do socio-ecological research. And what are the values of natural scientific research? This kind of research aims at objectivity and reproducibility, while in social ecology, there is an awareness that the research is a social process, entangled also in historically contingent social values and norms, as stated here in this table. And I would like to give you a short introduction in what are underlying concepts of social ecology. but because the focus of social ecology lies on the interaction of social and natural systems, always in the context of globalization, global change, or sustainable development. And there are two very prominent underlying concepts to study social-ecological systems. One is the social metabolism, and the other is the land use and land use change. So let me briefly and very quickly just show you the social metabolism. Social metabolism research is based on the assumption that the two systems, so the natural system and the social systems, reproduce, interact, and co-evolve with each other. By doing social metabolism research, this means that systematically flows of biophysical resources are quantified. So this is a very quantitative approach of tracing extraction of material and energy from the natural environment into the socio-economic system, but also tracing, quantifying the use of these materials for socio-economic activities, for example, feeding people, feeding livestock, building artifacts. And these socio-economic activities differ, of course, significantly from place to place, from country to country, from eLTSER region to eLTSER region, which depends very much on the culture, legal and institutional framework, and also on the economic conditions in the different regions and countries. And finally, this approach also tracks for the output of waste and emissions that is going back to the nature again. And all these activities, of course, have clear impacts and effects on ecosystems. In order to provide socio-ecological metabolism, so to extract resources, land use is one of the other key concepts, which involves human intervention in natural systems in order to optimize these systems for the human needs and human activities. So land use is not seen as the status quo, the system is more a process. And societies use land always for multiple purposes. So, for example, land is used for space, for infrastructure, it is used for provision of ecosystem services, or used for the provision of material and energy inputs, again, to be used in the social metabolism, the socio-economic activities. Let me just give you one short example where social ecology makes one or two steps before ecological analysis starts. I would like to talk about how important it is to differ or to make a distinction between land use and land cover as concepts. So land cover describes the state of a terrestrial ecosystem in terms of biophysical characteristics like geologic, climatic, ecologic characteristics. On the other hand, land use already includes this term of use, and that describes socio-economic activities that make terrestrial ecosystems, again, more useful for the use for the socio-economic systems. One theme of land use research in social ecology is also the transition, how these land use regimes change over time. So with demographic and economic transition, societies seem also to follow a sequence, kind of a sequence of different land use systems. So very common sequence would be from pre-settlement, natural vegetation to frontier clearance, to subsistence and small-scale agriculture, to intensive agriculture, and finally to urban areas, built-up areas, or protected areas as well. And I would like to give you a short example by focusing here not on a small scale, on a regional scale, but on the EU 27 scale, when we try to analyze the evolution of area used for cereal production. As you can see here in this graph, here you can see the trend of area in the EU countries from 1960 to 2010 onwards, and we see very little change. So the area decreases slightly from 1980 onwards, but in general, does not seem to be much change over time. But if we also plot the data on yields over the same period, in the same area of the 27 countries, we see a huge change with yields in the EU increasing more than 2.5 times between 1960 and 2010. So while the area under cultivation has remained more or less stable, the production on this land has increased significantly due to land use intensity increase. And finally, if we also add the curve of fertilizer use and tractor use, we also see that both indicators increase in parallel with the yields, at least until 1980s. The reason for that is that technical improvements in fertilizer application, but also political regulations on the maximum application rates have reduced this use of fertilizer and tractors. So consequently, what we see is that we really have to focus on these kind of drivers and very complex dynamics that lead at the end to different land use types, and especially land use intensities and different patterns of this land use and land use intensity. And it was also important is to be aware is that different parts of the world are in different stages of this transition. So also depending on the history of this different places, on the social and economic conditions, and also, of course, the biophysical ecological context. So that means that not all parts of the world move also through this transition in a linear way. So some places remain in one stage for a long time, others move rapidly between the stages. Also, the drivers of change are not equally important in different regions. They very much depend on the geography, biophysical and socioeconomic framework conditions. And this is why it is so important to have this sub-national regional scale provided by eLTSER platforms in order to analyze and get a much better understanding of these dynamic processes underlying this result of land use change that can be measured and seen. I chose this example of area or changes in area yields and fertilizer over time because I wanted just to illustrate the importance of data, especially data at the regional scale and especially data over a long time in understanding socio-ecological systems or changes in socio-ecological systems of a country or region. But as mentioned also in the beginning, in eLTSER, it is also not only important to have this kind of quantitative data available, but also qualitative data and qualitative understanding of the processes and the underlying processes, as well as interaction with stakeholders. So the transdisciplinarity, as shown here, is therefore at the heart of eLTSER as well. And as you can see here in one graph of Daniel and Jan Holzer, the conceptual model of transdisciplinarity research shows the need for a constant, permanent, iterative, participative process. And this cannot take place on the site level for sure. This is where platforms are really needed. So what does transdisciplinarity mean? It means kind of stakeholder integration, so stakeholder engagement in different phases, integration of stakeholders or the integration of the regional issues into the research agenda, which is also linked to the term of co-design already of research questions and projects taking place there. Knowledge creation with participatory methods, which is linked to co-production, so doing together the kind of research learning together, researchers and stakeholders, and also the impact and communication of research, which links to the implementation of research and learning outcomes. The overarching question for developing a platform, I would say, is that it's always the question, which kind of stakeholders need to be integrated and in which way they need to be integrated, and how can stakeholder integration for eLTR also be kind of standardized across the platforms. And this is the big challenge we are facing when we talk about standard observations in social ecology and across different eLTSER regions. But yeah, this is where we are working on. And finally, what is the eLTSER platform or the management? How can it act as a boundary organization? What are the tasks of these platforms? It's important to establish cooperations with regional stakeholders, also to identify and provide incentives for the stakeholders, a very important issue in my view, to build and maintain networks, also to provide researchers with access to stakeholder networks, which is extremely important whenever you try to build up a transdisciplinary project, to have the stakeholders attend that are interested in collaborating, and also facilitate exchanges between researchers and stakeholders. And for doing this, there are some kinds of preconditions that are necessary for a successful collaboration. And this is just some examples of prerequisites. This could be interactive workshops. This could be an in situ component in the region. This definitively must be a kind of attachment of the stakeholder to the site or the platform. It must be co-design, open sharing of knowledge and learning, also feedbacks, the implementation of feedbacks between researchers and stakeholders. And one of the most important parts here named as the last one is funding, of course, that allows to be really a long-term boundary organization between stakeholders and research. Yeah, with this, I would end my presentation and hand over directly to Daniel.
Can you see my screen?
Yes, we do.
Okay. Thank you. And thank you for Veronica and Terry and for everyone who participated in putting this together. I realized looking at the names that I actually don't know most of the people, and I probably have never given a talk to most of the people who are here, despite the amount of talking that I do. So what I'm talking about today really brings together what Stefan presented in the first presentation and what Veronica presented in the second. That is, we are making great efforts towards harmonization and standardization of the work that we do across the research infrastructure. That, as Veronica presented, social-ecological research is largely or very intensely place-based and stakeholder integrated. So really, we have a bit of a conflict. On the one hand, wanting to give full expression to the work that's being done in social-ecological platforms, and at the same time trying to bring them together into some sort of coordinated research effort. In previous lectures, I would call it herding cats, trying to bring everyone together while they're all trying to walk off into their own directions. But when we wrote up this document, this is the document that I'm going to present, is the platform specifications. Now, Stefan presented them for sites, so I'm going to do the same for platforms. And in very general terms, we are talking about geographically defined place-based areas for transdisciplinary long-term and social-ecological research. We primarily focus on environmental challenges occurring at the regional scale, and try to, in the normative effort, try to bring scientific information to the good of sustainability transitions. Try to use our research to direct policy, or at least to advise policy. And of course, we're supported as eLTER, we're supported by long-term environmental and social economic data. Now, I told you before that we have an inherent tension that on the one hand, our platforms are stakeholder driven, they strive for local policy relevance, they're based very often on bottom-up kind of organization. They let the platform bring the problems to the fore. On the other hand, to get all those advantages that Stefan talked about a research infrastructure, to be able to compare between platforms, to be able to conduct research across a social-ecological or an ecological gradient, or to try to advise on continental scale policy, then we have to work very hard to harmonize and standardize the work that we're doing, at least to the level so we have some degree of comparability, so we can take advantage of those of the work that we do. So now there's two characterizations. I have something covering my. No, okay, I'm sorry. I had something covering my title. So I used to present this as mandatory criteria and optional criteria. Now I try to define it as the harmonized component of the platforms and the independent or the self-expression component of the platforms. So the harmonized components are mandatory criteria that are going to be required of all platforms in eLTER-RI. And those criteria are laid out here. One is that they have a specific spatial design with explicit boundaries that are noted, that are explained, and that are loaded onto DIMES in GIS format. And that those boundaries have to be compatible with the types of questions that they're asking. So if you're looking at particular questions across a landscape, if it's agricultural impact, if it's logging, if it's watershed issues, then the boundaries of your platform should comply with, or at least be aligned with your research questions. And every platform should have a eLTER site within, whether it's category 1, 2, or even 3. That doesn't matter, but what it does have to have is have long-term ecological data feeding into its research program. These platforms have to be managed and financed explicitly. This is something in the past that didn't exist, but as we go through this ESFRI process in becoming a recognized European research infrastructure consortium, we have to have binding agreements in each platform with commitments of an institution that supports the platform, documentation of responsibilities, and a memorandum of understanding with both the supporting institution, but also the relevant stakeholders like those that Veronica pointed out in her presentation. That is, already in the memorandum of understanding, the platform has a commitment to its local community, to its supporters, to anyone who will be impacted or wants to have an impact on the research that's done there. The research itself is human-centered, apropos social ecology. It has policy relevance, and it supports the other functions within eLTER-RI of transnational access, and RA is remote access and DA virtual access. The data, now here's where I'm leaving the data for last. The data is the sticking point. The data is something that has utmost importance because we also have our standard observations. We've been working, as Cremona was asking for questions, I was answering one at a time saying, we're working on it, we're working on that, because we really are right in the kind of peak of working on these things, and we are delayed behind the other groups because this is really, I think even globally, one of the first efforts of any research infrastructure to try to set up a set of harmonized and standardized social ecological observations. So we're really delving. There are some theoretical papers that have been written on it, but this is really, I think, the first effort at a global or continental scale. So I'm going to come back to data afterwards because in our specifications, it's the data collection currently that separates between a category 1 and a category 2 platform, as we also have divisions like what Stefan presented, although they are determined by different factors as the ones he presented for sites. Every platform should have human resources. When we're doing cost analysis and we're talking with our colleagues within eLTER, we always have to really emphasize the point that we're basically talking about human resources, about researchers. We're quite a bit less dependent on heavy equipment and infrastructures because so much of our activity is based on social research. Although there are some data needs, some equipment needs, mostly what we need is people who work in it, who can work with stakeholders, who can manage data, who can conduct research. So a lot of our expenses are kind of corralled in this human resources. And also stakeholder engagement. Every platform is expected to be well integrated with local stakeholders. Of course, it's context specific, who those stakeholders will be, but they are expected to work in a transdisciplinary way where they're both providing and receiving information and developing or co-producing research knowledge with stakeholders. And now the other part of this is the self-expression. Where do we allow individual platforms to go their own way without being held or being confined to kind of the harmonized expectations? Really, every platform has its own research team. The spatial design will also be determined by local context, the size, the types of land cover that would be inclusive within. The only thing that is required as far as the spatial design is that it be explicitly justified and that the boundaries be recognized and submitted into DIMES, into our data repository. Now, this is really, I'm presenting this for the first time because really this conversation has only come up within our social ecological theme group in the last 2 months. So we're working on this as I present it, is that we're going to have 2 categories of platforms. And the difference between them is the resolution and precision of the data that they're collecting. As Stefan presented, we have prime and we have basic methods for collecting the data, and category 1 platforms are expected to collect using prime methods and category 2 using basic methods. I have one example for that, or 2 examples, excuse me. For instance, population size is a standard observational variable for platforms. How many people live within the platform? The basic method would be using publicly accessible European scale census data, in this case, NUTS-3 census data, to estimate how many people live within the platform. Now, we know that that may not necessarily be the right number because platform boundaries don't necessarily correlate with geographic or census boundaries. But for basic scale demographic SOV, standard observation, that would be enough. But for the prime method, we expect to have a more precise estimate of the population that lives within the platform. And that would be based on either national or local population census data. So the European census data, the basic method, is quite easy to access, publicly available. So that would be a category 2 platform, but the prime method demands a little bit more investment in extracting the information. Likewise, if we were talking about a particular ecosystem service, then as we're developing these processes now, the basic method would be an estimate by the platform manager, whether that be categorical or a logarithmic scale, but it would be an estimate based on expert knowledge. While the prime method would have to have a quantitative or an empirical underlying value that's expected to be far more accurate, or the actual value. So that's kind of the difference, and that's where the difference lies between category 1 and category 2. And as I emphasized before, this is a work in progress. Just to conclude, we want to say the good things about the platforms, because for those of us who have been working in them for a decade or more, we believe in this type of research. We believe this is a backbone component of eLTER-RI that aspires to this whole systems approach. And we really bring the social component and the integrative component to the forefront of our research. And this is where stakeholders are engaged, and this is where policy is engaged. Platforms will undergo periodic audits as part of the general social economic impact assessment process within eLTER to assure that we're aspiring and meeting our expectations and working towards our objectives. And another emphasis that it's really the soft infrastructure, as far if we're considering where the money is usually invested in a platform, or at least where we expect it to be invested, it's mostly in that soft infrastructure, salaries for professional staff who can conduct the research and also work with communities. In one map that we made from our DIMES repository, this is where all the platforms are across Europe. We don't know if this map will be similar after we get through this ESFRI process, but I hope to see the map much the same after we emerge at the other side of this standardization process that we're going through. So thank you.